This is our third episode in this series with one of Nosco's valued customers, Phil Harrison, co-owner of Dura-Pack. Today we're going to be talking about automating your flexible packaging. Welcome back, Phil. Thanks again for being with us.
Yeah, thank you, Steve. Pleasure to be here.
So, can you talk to me a little bit about what it looks like to start the journey of automating my process for flexible packaging or filling, things of that sort?
Yeah, great question. So, and we see a lot of like misinformation and confusion in this space, so I'm glad to get to talk about it. So, a common mistake is people tend to over-automate, right? So you get this process and there's this vision of all these magic robots doing all this stuff with no humans. And they tend to over-invest and over-automate, and it's, typically to their dismay. So if you kind of walk through the process, so you have your new product, and typically you start off with literally a scoop and a scale, right? So you've got your bag on a scale, and you manually scoop product into it and run it through some type of a heat sealer. If you're doing dozens or hundreds a day, you're going to live in that space. Gotcha. And then when you start going from hundreds to thousands, now you start buying automation, but you're running it more in a semi-automated process. So you're still not trying to automate everything. So instead of a scoop and a scale, now you have a machine that'll do the weighing and dispensing, but you're going to put the pouch over it, hit a foot switch, and run it through a sealer. So now that human, instead of doing hundreds a day, can now do thousands a day.
Gotcha.
And then you're going to live in that space for a while. And then when you exceed that, where you're doing thousands or tens of thousands, now you're looking at automating even more to where you've got your automated filling process, but now you're going to automate the pouch handling too, where you just put in a bunch of pouches, and now you have automation that's going to open, fill, seal your pouch, completely automated.
Sure.
And when you get really, really big, you actually go away from pre-made pouch filling. And now you're actually just buying raw material, you're buying printed film, you're buying zipper material, and it's a much larger, more complicated machine, but it's actually going to form the pouch, fill it, and then seal it all in one high-speed machine.
Great. Well, thanks, Phil. So basically, what I'm hearing you say on that process is we're kind of scaling up from startup or small throughput, small company,
Yep.
and then scaling up kind of to the large brands.
You got it.
You had said once before, big CPG would be kind of in that space of full automation, roll stock converting, things of that sort,
Yep.
right?
Yep.
So I've got that right?
You do. And there's an interesting, though, even at the large scale that we've started to see, is you have these huge machines that run really, really fast.
Yeah.
And with the variety that we see, sometimes we'll even see a pivot where a large CPG, instead of having this one super high-speed machine, they'll just do multiple low-speed machines too.
Okay, that makes sense. And I guess I would ask one question too. How does that fit with multiple different types of items, SKUs, things of that sort, right? You've got specific lines for that, I would imagine.
Yeah, and that's one of the big reasons, especially today with like allergen concerns. So picture you have this huge high-speed line, and then you just ran peanuts.
Sure.
And now you need to run it allergy-free. That's a huge cleaning, sanitizing cycle. But if you have multiple lower speed machines, they can be in separate rooms. You don't have to worry about cross-contamination, et cetera, et cetera.
Sure.
Yeah.
So as you do that and you look at different styles of equipment, what are the different things that a brand might need to consider as they're evaluating what kind of a line they want to put in, what it's geared for, how they're going to create that environment for that particular line?
Yeah, there's a lot of things that people don't often think about in the front end, and that is like, where am I going to put it?
Sure.
How am I going to get it into the building? Some of these machines are really, really huge, and so even if you've got a ton of floor space, people don't always look up. So you got a ton of floor space and an 8-foot ceiling, and these machines stack vertically. So
Right.
It's very common you need 12, 15, 20-foot ceilings. That's often missed. Or you've got the biggest space in the world, but your building just has a tiny man door, right? You won't fit the machine through it.
Sure.
There's a lot of utility requirements and consideration. So it's a lot of pre-planning on the front end, working with an equipment supplier and doing CAD drawings and things like that, and then working through these phases.
Understood.
Yeah.
And when you talk about like the right weight, fill for your product, what you're putting into it, contents, kind of walk us through the process that you go through in terms of getting the right volume, I guess, for lack of a better term, right?
Yeah.
Of what I'm trying to do for the
Yeah,
package.
and you kind of hit the nail on the head. There's 3 core different technologies to basically fill product. So you can weigh the product, and a lot of products are sold by weight. So we always say, measure it how you sell it. So if you're selling by weight, you should probably fill it by weight, right?
Sure, that makes sense.
And most weight-based systems have some type of a vibratory feeding device or something to transfer the product, going into some type of a scale bucket to hold the product and weigh it on the fly.
Okay.
There's a lot of different variations, multi-lane machines for mixing and blending, but at its core, you're dropping or vibrating something into a scale and weighing it before you drop it, and those are weight-based systems. You also have volumetric systems, which are commonly used in powders, and a lot of these products are still sold by weight, but what they do is you basically have this big screw auger in a column, and then you sit there and it's kind of guess and check, trial and error. It's like how many revs of the auger will give you the desired weight.
Okay.
And you sit there and go back and forth. That technology shines in that it's fully enclosed for powders, but it kind of suffers in the accuracy department because it's more of a guess and check type principle, right?
Okay.
And then the last method is counting. And so the way counting works is you're typically orienting or using some advanced vision system where you can cascade product, and either using orientation and low-cost sensors, you're just counting them as they drop past like a laser sensor.
Oh, sure.
Or some more advanced systems, you can actually waterfall them off, and with high-resolution CCD, they can actually count them in midair, which is kind of cool. So you're not weighing it or anything like that. You're literally just counting
the numbers.
Yeah.
You've got a much more accurate fill, right?
And so the counting is typically used in things like pharmaceutical pills, things like that. You can count by weight if you have a consistent piece weight. So if you have a consistent piece weight, you're usually better off just weight counting, because if you actually drop 2 or 3, the scale knows that you have 2 or 3. But there's a lot of products that don't have a consistent piece weight.
Sure.
So then if you try to count by weight, the math doesn't work out, right? And you're always going to be plus or minus something.
Gotcha. That makes sense.
Yep.
So Phil, in our prior episode, we talked about the film components and packaging, barrier to help shelf life for my package, but I know that there's some unique things I'm not aware of that we do from a filling perspective that kind of also aid in this matter. Can you explain to me what that is?
Yeah, good. Yeah. So there's something called MAP, modified atmosphere packaging. Some people refer to it as gas flushing.
Okay.
And so we have all these cool barriers that keep oxygen from getting in, but the air that we breathe is roughly 20% oxygen.
Right. Yeah.
So when you pack the product, it's chilling out in 20% oxygen, right?
Mm-hmm.
Just eroding the product, et cetera, et cetera. So a lot of products are degraded by oxygen, right? So to increase the shelf life, the first thing you need to do is not let the oxygen in. But ideally, what if you get some of that oxygen out? So what they do in MAP, gas flushing, and the common gas used is nitrogen. The biggest reason, because we have a ton of it and it's cheap, right? And basically what you do is you flush nitrogen into the pouch, and all you're really doing is you're pushing the oxygen out.
Gotcha.
And then you go from 20%, and it's kind of industry and shelf life specific. Like a lot of snack food guys try to get to 3 to 6%, 2 to 4%.
Sure.
A lot of coffee guys try to get to 0%, like parts per million.
Right.
Things like that.
Mm-hmm.
And so what that does, but just by pushing the oxygen out, it extends your shelf life. But you have to make sure if you are gas flushing, you are using a high barrier, because if you have a low barrier film and you gas flush, guess what happens? You're gonna get 20% oxygen right back in, right? And there's other cool things you can do to help protect the product. So you can nitrogen flush a pouch and not blow it open like a pillow. Like you could pick a pouch off the shelf and not even know it was gas flushed.
Sure.
But like chips is a really good example of how to lift out with air. And a lot of consumers are like, oh, I'm getting screwed over here with half a bag of chips. But they do that, one, to protect the product in transit, so you get more whole chips. And two, it's a bunch of nitrogen in there to lower that to 4 to 6%, so they don't go stale on the shelf.
Gotcha. That makes sense. So, as we talk about MAP process or gas flushing, is it always the case that when you're filling, you're doing that, or is it just some of the time? I mean, how does that all work?
Yeah, good question. So it's very product specific.
Okay.
There are some products out there that are actually naturally shelf stable. So the biggest thing to do is to work with a lab that does formal shelf life testing.
Sure.
And they will run an accelerated test and in parallel run like a real world test. And basically what they're going to find is sometimes you might be using a low barrier film and literally just going to a high barrier film, you're done.
Does what you need
shelf.
to do,
Yep.
right?
What some people will do is they get to that, but they still gas flush, not to extend the shelf life, but it's kind of like a safety net, right?
Sure.
It gives them that little buffer.
Little
period.
extra.
You got it, yeah. And then some people are like, I need this super amazing shelf life, and then you just have to do both.
Got it.
Yep.
Understood. Mm-hmm. That was a great explanation as to gas flushing product and stabilizing or getting my product ready for an extended period shelf life. I always see on my packages, right, the expiration date, which I know is an important aspect of packaging your product on X date, it's good until Y date. Can you explain to me kind of that process? How do we get that there, and what other things are important to consider?
Yeah, great question. So the kind of like the lowest cost poor man's way of doing it is what they call like an emboss, like a thermal emboss.
Sure.
And, you know, you have to put a heat seal at the top of all these packages after you fill them. So you can literally embed characters into that. And if all you're really doing is like a Best By date or maybe a small lot code, you can get by with that. The downside is typically when you open the package, you lose that.
Sure, right.
So that if the product is stale and you call, well, you just lost a lot number, right? But usually you've got more data and things like that, and that's where you get more into like inkjet printing and thermal transfer and labeling, because not only can you put the Best By date, but you can put lot and traceability information and even variable data related to your SKU. And those are the higher end technologies that give you a lot more features than just, you know, a basic one line Best By, whatever it is.
Sure, makes sense. With regards to the serialization aspect and variable data aspect of things, how often are you seeing, I mean, this is like a changeover every time you would run a line, right? As I understand it.
Yeah.
So are your customers utilizing that on a regular cadence in terms of their traceability and lot and date coding?
Yep. Yeah, it is a pretty big requirement, and one of the challenges is if you look at the technologies we have on the packaging lines, they're pretty low fidelity print, and it's easy to like miss a character or have something go wrong on the line, or if you're packaging a liquid or a messy powder, it can mess up and clog up the jets, et cetera, et cetera. And you could speak more on this, I think, but one of the cool things is like what you guys are able to do with your assets and variable printing.
Right, yeah, well, that's a good point. I mean, we are leveraging HB Indigo digital print technology for all of our flexible packaging, and that allows us the opportunity to basically variable print on each individual package, a particular lot and date expiry if that was the requirement, manufactured date, etc. But we could also item level serialize that, customize it to that specific package if that were something that our customers or you needed us to do.
Yeah, and it solves a big problem for the end user, because not only do they not have to buy this big expensive date coding device, it kind of error proofs it on the plant floor of, you know, data entry and things like that, but now they don't have to worry about like missing a bar in a barcode or whatever, because your technology is so much high resolution than what you'd ever see on a factory floor.
Right, right. So Phil, we've walked through the filling process, we've walked through the gas flushing process, we've stamped our package, and now we've got to get ready to ship. And I'm guessing we'd have to inspect or check that in some way, shape, or form, right, to make sure we're good to go.
You got it.
What's going on here?
Yeah, so one of the big things you always want to do is check that whatever your filling machine is designed to do, it actually did it, right? So, you know, if you're filling by weight and you're supposed to be doing 16 ounces in every package, you don't want to undership. That's a pretty huge penalty through most distributors and retailers, right?
Sure, yeah.
And you also don't want to drastically overfill, because you're just going to give away your product. So one of the first common machines is some type of an integrated check weigher. So every package is going to go off as another scale and double check. And if it's out of tolerance, it'll actually get pushed off the line.
Okay.
And every once in a while, if that happens, it's a little bit normal. It just means something weird happened on the line. But if you start getting a lot of those, now the alarms go off and you know to go address a problem on your line.
Got it, understood.
So that addresses that the consumer is getting the weight or the count that, you know, they purchased. And now after that, you have foreign material, right? So we've all seen the viral things now with like, oh, there was a Band-Aid in my food or whatever.
Right. Unfortunately.
Right? Yeah.
Unfortunately.
And you can see when you're in these plants how easy it is for something to happen on accident, but it can destroy a brand overnight. So the original way of doing this type of inspection was a metal detector, which would detect, you know, things, ferrous products and things a metal detector can.
Right.
You know, that prevents nuts and bolts and machine parts accidentally falling in. To really work well in a plant, you actually have to invest in everything in your plant metal impregnated. So metal impregnated Band-Aids and hairnets, you know, and all the stuff that could end up in a package. But the ultimate in package inspection is actually X-ray.
Oh,
so
okay.
they have these extremely high-end units, and it's really similar to what you go through literally at the airport, right? They can just run high speed, and so they can actually look inside your package. And, you know, if you have something that comes from like the farm or whatever, where you can literally end up with bone fragments from an animal, right? This thing can actually look at it and pick all those things out. So that's the ultimate that we highly recommend. But at a minimum, you definitely should be doing metal detectors. protection.
Metal detection?
Yep.
Got it. And that's all for safety and compliance, quality product going out the door, keeping consumers safe and healthy, right?
You got it.
And that's
Yep.
really the whole focus.
That's the whole point. Yeah.
Yeah. Well, Phil, thank you so much for all of that great information. Obviously, it certainly kind of walks us through that process of starting on smaller scale operation from a filling perspective, all the way through, high speed, high scale, large organization aspect for pouch filling and things of that sort. I'm so grateful that you joined us today. It's been just a tremendous amount of information. I have found great value in our discussion. Thank you for all that you've offered. And
Yeah, thanks for the opportunity. It's been a blast, Steve. Thank you so much.
So next time we're going to be talking about proper pouch sizing. So we'll definitely want our viewers to come back and join us for that discussion, because that's going to be a critical component as it all ties into this process.
Yep.
If you're interested in this content, go ahead and click the link below for additional resources. Don't forget to like and subscribe. Stay with us for next time when we talk about proper pouch sizing. This is Nosco Unpacked, flexible packaging made easy. See you next time.